Let's do that. Okay, couple of announcements today. So final is a week from today. Remember to come at noon next Monday, not at 1. Also, I did post some additional objectives for the smallpox, monkeypox that we will get to today. So pretty much for these pathogens, I said, think about the transmission, think about the organism or the virus itself, the morphology of it, for instance. Think about the symptoms that patients have, virulence factors when we talked about them. So I just posted a few more specific things for the smallpox, monkeypox that I hadn't posted at the beginning of the semester. So that's under the learning objectives. There's just another, a few more there. The other issue that one student had brought to my attention when she was working ahead on the RNA viruses, the HIV section, and the homework questions. When she opened that part up with the HIV, I forget what chapter that is in. It's under the viruses of the circulatory system. There were some pictures and a graph and no text other than that, and then just some homework questions. If anybody has had that happen, it was suggested to me that you want to close your browser and maybe shut down your computer and start it up again, that there may be an issue with OpenStax not loading correctly. So again, there should have been a bunch of text that would have helped you answer the homework questions. So I don't know, if you're encountering issues like that, let me know. And I can contact OpenStax if it's something that's happening widespread, but just to be aware of that. All right, so let's finish up the herpes viruses today, and then we'll do a few review questions before we move on to another genus of double-stranded DNA viruses. But last time we talked about HHV1, which is typically cold sores, HHV2, typically genital sores, and there's a lot of unique things about that herpes viridae, I almost said genus, family of viruses. But one is that they have the ability to go latent. So remember, we said they went latent as episomes, so they don't actually integrate into our cells' chromosomes. They integrate as little kind of plasmid-like structures, but they don't ever come out of our cells. They're really closely associated with the chromosome. And HHV1 and 2 happen to go latent in nerve cells. One of the different branches, either the trigeminal nerve ganglion, the brachial ganglia, or the sacral ganglia. And then they will reactivate from time to time. In other words, the virion will start replicating again, and the host will have symptoms again. What causes that reactivation? It can be a lot of different things. Usually some kind of stress, and it might be things that you don't typically consider terribly stressful. Sometimes sunlight, right? Maybe a day at the beach can cause some sores to reactivate. Just a person's normal menstrual cycle. Any kind of immunosuppression. So that's kind of a catch-all for maybe the host is taking some immunosuppressive drugs like steroid treatment or prednisone or something. Maybe it has to go, host has to go undergo chemotherapy, something like that. Maybe they're sick with something else and they have a fever. My husband hadn't had a cold sore in 25 years. And I think maybe I shared this earlier in the semester, but when he had his second COVID shot, he got a cold sore. It's like, oh man, I haven't had this happen in a long time. Typically, over time, as the sores reactivate, they typically are not as severe as the first time. Our body does make some antibodies. And I guess if there is good news, they're typically less severe over time. Okay, so do we have treatment? One drug that's been around for a long time is called acyclovir. And your book talks about a couple of other drugs. They're really just kind of variations of acyclovir. So we'll mention them in particular. But this drug is a nucleoside analog. So we talked about this when we did our chapter on genetics. Remember, a nucleoside, here's the deoxyguanosine nucleoside. That's the base, in this case, guanine, along with the sugar, in this case, deoxyribose. Okay, if it was a nucleotide, it would also include the phosphate. Okay, so that's a nucleoside. Acyclovir is a nucleoside analog. That means it's similar to the structure of a nucleoside. So here's acyclovir. It's got guanine, the same as the guanine nucleoside. You can see, though, the deoxyribose is not really that close. There is no 3' hydroxyl group here. So if the virus incorporates acyclovir instead of deoxyguanosine, then the chain is going to be terminated. You can't add any more nucleosides on there because it doesn't have that 3' hydroxyl group down here. Okay, so it's a way to kind of stop replication of the virus. Viral polymerases are generally a lot more indiscriminate. Our polymerases, remember DNA polymerase 3, that's the main enzyme in replication. It makes very few errors, and the errors that it does make, it usually is able to fix them. Okay, so viral polymerases, again, not that high fidelity. They'll throw anything in there. So when they do throw in acyclovir, that halts their replication. So that's a drug that's given in lots of different forms. It's given as a cream, it's given orally, it can be given by injection to just try to reduce the length of outbreaks that a patient experiences. In terms of cold sores, there's some over-the-counter stuff like menthol and camphor, just to kind of reduce that irritation there. There is some prescription medications that I was reading a little bit about, but you have to apply them like 5 times a day, and it only makes it heal maybe a day faster. So they're not terribly effective. Every semester I look into a herpes vaccine. There is one that's been languishing in clinical trials for many years to be given after somebody is infected with genital herpes. Again, that's usually HHV2. So not to keep somebody from contracting it, but after they're already infected. It's not approved by the FDA. I imagine that it's not terribly effective, and that's why it hasn't been approved. But they are working on an RNA virus, an RNA vaccine that would be helpful for herpes treatment, but it's not out yet. So interestingly enough, so when you start, Googling things about a disease, it can kind of take you down rabbit holes. Interestingly, one number, the WHO, the World Health Organization, estimates that 500 million people worldwide are infected with herpes. It's difficult to know, really, but that's their estimate. And in California, it's against the law to willfully give somebody else a sexually transmitted disease. Didn't know that. You can also be sued for that as well. So might be an interesting topic of discussion if this was a discussion-based class. But We'll move on. Okay, two more kinds of herpes virus I want to talk about, HHV3 and HHV4. HHV3 is also called the varicella zoster virus. And varicella is Latin for speckled, and zoster is Latin for belt. Okay, so the speckled maybe makes a little bit more sense because this is a causative agent of chickenpox. We'll get to the belt parts in a minute. So this is an infection that's not transmitted when you're near chickens. I think it reminded somebody the rash that develops as what the skin of a plucked chicken looks like. Perhaps that's where it got its name. But this is an infection that we are passing around human to human. You have to be in direct contact. Again, respiratory droplets, typically less than 1 meter. Okay, it's not considered airborne. Maybe in rare instances it could travel a little bit further than that, but typically close contact. You've heard me maybe talk about before how this is a very contagious disease. Before we had a vaccine, almost everybody had this. And the reason is that it is infectious during many different stages of the illness. It's infectious during the incubation. So remember, in the incubation stage of a illness, do you have symptoms? No. So you're walking around feeling fine and actually can be giving other people chickenpox, and that may be 1 to 2 days. So you can be infectious during the incubation period, during the prodromal period, which remember is kind of general symptoms. Usually when kids get chickenpox, there's really not much of a prodromal period. They're pretty much, they're infectious a couple days before the rash breaks out. And then they really kind of plow into full-blown illness pretty quickly. And then people are infectious through the illness period until the rash scabs over. So it's pretty long, at least a week that people are infectious. So that's a recipe for a highly contagious illness, when people are infectious even when they're not showing symptoms. Of course, we saw that in COVID, especially early on with the early variants. So this seems to be a good time to talk about how infectious an illness is. They don't mention this in your book, but it seemed to be a good time to talk about R0. So this is how we pronounce this, R0. And this is a way that we express the transmissibility of an illness. This is a calculation that can be made, taking many different things into account. A calculation of the number of people that one sick person is likely to make sick. Okay, and it assumes, though, that the entire population is vulnerable. So that's what kind of makes this confusing and kind of what makes it difficult to maybe nail this down exactly and why you read different things. But if you look at the R0 for chickenpox, for chickenpox, it's about 10. Okay, so again, before we had a vaccine, assuming that everybody that you came in contact with was susceptible and you came down with chickenpox, you would get about 10 other people ill with chickenpox. So that's pretty infectious. If we compare that to some other illnesses, flu is typically about 1, maybe 1 to 2. So that's sort of the garden variety influenza. We'll talk about that infection next time a little bit more. The original strain of COVID was maybe about 3. So that's what we would now refer to as that alpha, that original strain. Sometimes that's estimated again, somewhere between maybe 2 and 3. So just a little bit more infectious than influenza. Delta variance was maybe about 5. The latest Omicron variants, I read different things about that. Probably Omicron, probably somewhere between 7 and 9. With that BA1 variant, probably even more than that. And then again, I've talked about this lots of times, how measles, that's why we have to keep our vaccination up, because, you know, one person that's infected with measles is likely to make, 18, I wrote that wrong, 18 other people ill. So something that's just sort of interesting to think about. Okay, and of course with the COVID picture, with people being kind of, you know, taking into account when they got the vaccine and whether they got boosted or not, you know, people had only the original ones and didn't get boosted or whatever, that makes it a little bit harder to calculate the R naught. So symptoms of chickenpox. The rash is the big thing that you think about. That starts in the trunk region. Okay, and when kids get sick, that's usually the first sign that they're sick. I remember I was 8 when I got chickenpox, and I was going to swim lesson, and my mom happened to notice that I had a sore kind of right on my neck, and she said, "Oh, we're not going to swim lesson today." Right, so I felt fine, but I was probably out passing it on to other people. That rash spreads. They're kind of small fluid-filled vesicles, and they're very itchy until they scab over. Of course, when the scabs form, then they get even itchier. When adults get chickenpox, they might have a little bit more of a prodromal period. So they might have a couple days where they're feeling a little bit lousy until the rash breaks out. So rash, fever, malaise, loss of appetite. Typically not too serious. I can remember having sores inside my mouth and kind of in the back of my throat. I remember being absolutely miserable. But again, it usually resolves on its own. And good memories established, so people typically don't get it again. Sometimes if somebody had a really mild case or had it when they were really young, then there's potential to get it again. So when the vaccine to this came out in 1995 or so, there was a bit of a controversy because people said, why do we need to vaccinate for an illness that's not that severe? I was a young mom at the time, and I rushed out to vaccinate my one child at the time because I couldn't stand the thought of, it was selfish, I couldn't stand the thought of, you know, being stuck in the house for a week. And so I thought more of myself instead of my child. But there are some very good reasons that we do want to vaccinate against chickenpox. So I'll start with kind of the worst argument and build up to a better one. Well, I started with the worst one, that I didn't want to stay home for a week with probably a very cranky child. A better reason is that there are secondary infections that can potentially happen. When somebody's itching, that rash, the scabs, it's really easy to pick off those scabs before they're ready to come off, and it will bleed a little bit. So that's a good portal of entry for some secondary skin infections, like some kind of staph skin infection. Of course, the chickenpox is a primary infection, and then a secondary infection is one that would happen as a direct result of that. Less common than some kind of skin infection happening is something a little bit more serious, like pneumonia or encephalitis, a brain inflammation. That's pretty rare. A stronger reason, remember that this is a herpes virus. This has the potential to go latent. It goes latent also in nerve cells like HHV1 and HHV2, some of the same spots there. When this does reactivate. It reactivates in about 30% of people that had chickenpox. Later in their life, it reactivates as an infection known as shingles. Okay, and typically this happens later in life when your immunity maybe starts to wane a little bit. Shingles manifests as a painful rash, right? Chickenpox was itchy, shingles is painful. So you can see this, the most common place that it manifests is in the belt region. So that's zoster, Latin for belt. That's where that came from. But it can activate again, depending on which nerve it kind of goes latent in or where it reactivates. Sometimes we see it in the face, sometimes kind of the lower below the belt a little bit. Usually strikingly on one side of the body or the other. So this is very striking how it's only reactivated in one nerve, one side of the head. So painful rash. Of those that get shingles, though, about 10% of those patients, the rash doesn't last just for a couple weeks and then clear up. It lasts on and on and on, and we call that post-herpetic neuralgia. Okay, so the pain can last for months. And I've talked to people that have had that, and it doesn't sound fun because we don't have a lot of treatments to kind of help deal with that. Somebody with shingles, they can't give shingles to somebody else, but if they're around, say, a baby that hasn't been vaccinated for chickenpox, they can give chickenpox to that baby. Okay, so really when you think about, we'll talk about the vaccine in a minute, whether you get vaccinated or not, it's more of a shingles vaccine anyway, it's kind of more of a personal decision. Do you want to, mitigate your risk of ever getting shingles? I signed up, I got it right away. It's like, I remember chickenpox being so bad that I don't want to take the chance I'm going to have shingles. But yeah, there is that chance that you could pass it on to a baby. But if you never have chickenpox, you won't, in theory, ever get shingles. Okay, so that maybe is a good reason to vaccinate against chickenpox. Probably the strongest, and you can get shingles multiple times. Usually only once or twice, but sometimes people get it over and over again. Strongest reason, though, to vaccinate for chickenpox, age is a factor when you contract chickenpox. Okay, contracting chickenpox as an adult, say as a teen or adult, is much more serious. People are much more likely to have these serious side effects like pneumonia and encephalitis. It can potentially even be deadly. Dr. Baxter, some of you probably have him in lab. He had chickenpox when he was 15. And he said the rash that he got was not just tiny small pox. They were great big, quarter size sores, and he got pneumonia as a result of that. And he's really sick for a long time. So it's best either, to have chickenpox when you're young. Well, it's even better to not ever get it. Then you won't get shingles. I had a student say to me once, I never had chickenpox. I was never vaccinated, and I work in a nursing home. Should I get a chickenpox vaccine? And I said, yes, go make an appointment today, right after class, because older adults are more likely to get shingles, and you being around them, you could get chickenpox and you could be very sick. You could miss, weeks of school. You could, have some bad complications. So you want to, it's best just not to get it to begin with. Okay. let's see. So strong arguments, hopefully. What kind of treatment do we have? Let's talk about the vaccine. First of all, the Varivax, this is the chickenpox vaccine. It's an attenuated vaccine, live attenuated. Usually we give it to kids at about 18 months of age, and then a second dose about the time they go to kindergarten, maybe 4 to 5 years old. Okay, and that tends to give good lifelong immunity. Let's see what else. We do have also a couple different vaccines for adults that have had chickenpox as children to keep them from getting shingles. This was the old vaccine, Zostavax. That one protected, lessened your chances of getting shingles by about 50%. The new one called Shingrix, which has been in use for maybe 3 years or so, is about 90 to 95% effective. So it works a lot better, again, preventing the people that have had chickenpox of that reactivating shingles. It's an inactivated virus, so it's not a live virus. You take it in 2 doses. Unfortunately, there's a good bit of kind of inflammation and side effects associated with this, especially after people have had the second dose. And it's when I had the second dose, it was worse for me than what COVID was. I had it last year. I just remember laying there and just everything hurt. Then I took some Tylenol and I felt a lot better, so it wasn't that bad. But it is recommended for people that are older than 50. So, you know, over the holidays, maybe ask your family if they remember having chickenpox and if they've had their shingles vaccine. So encourage them to do that. Okay, really the only treatment we have, again, is acyclovir. Severe chickenpox cases that will kind of maybe reduce the itching associated with chickenpox, reduce the pain a little bit associated with shingles, but we don't really have anything else that's very helpful. Okay, any questions about chickenpox? Shingles, anything? Okay, I have heard of people, I heard of a high school person getting shingles once, so that's pretty rare, but most commonly when you're older. All right, our last herpes virus mentioned a few things about Epstein-Barr virus. That's named for the people that first isolated it. This is one of those viruses that can be potentially oncogenic, can cause cancer, but it's kind of a crazy virus. It can cause kind of totally different manifestations of illness. One disease that it's associated with is called Burkitt lymphoma. This is a cancer of the jaw. I should mention that this virus actually goes latent in a different kind of cell. It goes latent in B cells. Okay, so HHV 1, 2, and 3 in nerve cells, this latent in B cells. This Burkitt, and actually I've heard it more often called Burkitt lymphoma instead of Burkitt's lymphoma. Okay, pretty close. Seem to be calling it that more often now. This is a cancer that's most common in African boys. It's about like 50 times more common in African boys than it is in boys in the US. In the US, there's only about 300 cases a year. And mostly in boys. And I looked up that connection before class today, and it turns out that lymphomas in general are more common in males than females. They think estrogen production has a little bit of a protective effect in females. So we're more commonly seeing this in boys. Why African boys? We're not really sure. Sub-Saharan Africa, it's been suggested that there may be a link with malaria infection, but that hasn't been proven. So that's a little bit of a mystery. So it causes these really nasty cancers in the jaw, some often associated with some abdominal tumors as well. The good thing is that it's quite treatable. So chemotherapy and most boys that get treatment make a full recovery. Interestingly enough, some people, instead of getting cancer from this virus, get infectious mononucleosis. All right, and this is transmitted by saliva. So it has been called the kissing disease. So kissing, sharing drinking glasses is another big one. My daughter contracted this just in the summer, early fall this year. She's 26. She's a little bit older than normally. It's kind of teenagers, people in their young 20s. We'll talk about why that is in a minute. But she, yeah, we were at that restaurant that one day and we all, shared drinking glasses, and that's probably how she got it. She didn't have it very bad. Some people, when they have mono, they're exhausted for weeks and weeks, and sore throat. I'm sure some of you have experienced that. She went to the doctor because she'd been feeling poorly for a while, and they did the mono test and they said, nope, you don't have mono. And she said, oh, okay. She went out and she ran 6 miles. She's an avid runner. The next day they called her and they said, oh, no, we decided you have mono after all. So she then kind of took it easy for a while. But they say because it enlarges the spleen, you shouldn't do any contact sports because of the risk of rupturing your spleen, which would have the potential to be really, really bad. Okay, so it's an infection that although it causes somebody to miss a lot of work or miss a lot of school, it's not something that's typically long-term serious. Why does that just show up in young adults and teenagers? Well, there is some link with Epstein-Barr virus as to how it manifests in the host, depending on the state of the host's cellular immunity. So if you are exposed to Epstein-Barr virus, HHV4, for the first time as a young child, then typically you don't have any symptoms at all, kind of unusually. Some things are more serious in young children, right? So exposed for the first time as kids don't usually have any kind of disease manifest. If you're exposed for the first time as a teenager or a young adult, you have a very vigorous immune response, and that will manifest as infectious mononucleosis. I've heard that disease described as your T cells fighting with your B cells. Okay, that makes somebody exhausted. So the point is that you have too vigorous an immune response causes just a lot of inflammation and more cell death. Sub-Saharan Africa in boys that perhaps have a poor immunological response, among other things that we didn't talk about, that can manifest as Burkitt lymphoma, somebody that is pretty much lacking any kind of cellular immunity, any kind of T cell response, like people that have HIV, maybe full-blown AIDS, that don't have much of any response at all, manifests as this oral hairy leukoplakia, which is just some sores on the underside of the tongue. Okay, so kind of interesting that we get some different responses there. We don't really have any treatment for mono. Sometimes I've talked to people that have been put on steroids to try to kind of beef up their the right kind of immune response, or maybe dampen it. Maybe that's more, I think actually that's the case, to dampen an inappropriate immune response. Acyclovir, which is helpful for HHV 1, 2, and 3, doesn't really have any effect for mono. It can just decrease the amount of virus that is shed, but that doesn't help the patient. It doesn't help clear up symptoms any sooner. So, all right, any questions? we are a quiet bunch today. Let's do a few practice questions here. We've been trying to kind of practice all along. If we have time on Friday, I anticipate that we will. We'll start the RNA viruses probably Wednesday, then we'll do some more reviewing in class. This is one that trips some people up sometimes. Neisseria gonorrhoeae. We talked about how that organism really quickly changes the protein composition of its fimbriae. What do we call that mechanism? Yes, antigenic variation. I heard it. Good. This phase variation is when the fimbriae detach. Okay, so that's related. We're going to talk about this antigenic shift in relation with influenza. So some of those terms get a little bit confusing. This VGDJ recombination was the mechanism for how B cells and T cells make so many different B cell and T cell receptors. So we talked about that a long time ago. All right, which one of the following is a gram-negative coccobacillus? In fact, it might be good practice to think, let's see what all of these are. It's Bordetella pertussis. That's the coccobacillus, halfway between a round cell and a rod. C. diff, remember that's a gram-positive rod, as is Bacillus anthracis. Mycobacterium, it's actually, we're not going to call it gram-positive or gram-negative. We're going to call it an acid-fast rod-shaped organism. Strep pyogenes, gram-positive cocci. Okay, if you're in lab, hopefully you remember that. One more. All right, which pathogen carries extensive tegument proteins? Most of those proteins function to dampen the host immune response. Things like down-regulating production of NHC class 1. All right, we just talked about that one last time. That's the herpes viridae. Remember, that virion also has a pretty big genome, 80 to 100 genes, and all these tegument proteins within that virion. Double-stranded DNA virion. Okay. All right, let's keep going. We have another double-stranded DNA virus that I want to talk about. I prepared this material over fall break when I had a little extra time. And since then, I've thought of more things and found more interesting things that I wanted to say. So I might kind of cram a little bit more in here than what I had originally written. So this is a family, Poxviridae. Remember that family name of viruses always ends in viridae. We italicize them. And the genus is orthopox virus, which is kind of not as intuitive. And then kind of what the species names that I think there are some others, but these are the ones that we'll kind of mention. The variola, the vaccinia, cowpox, and monkeypox. All right, so the variola is the causative agent of smallpox. So originally I thought, oh, I'm just going to talk about monkeypox, but then I realized I need to talk about smallpox first before I talk about monkeypox. Variola major and variola minor are the two kind of variations of that variola species that causes smallpox. Okay, so variola major causes we'll say serious smallpox. I'd say disease with the worst outcome. Okay, mortality here is somewhere between 30 and 50% that contract it end up dying. Okay, so pretty high mortality rate for variola major. Variola minor, apparently sometime after about the year 1900, the virus changed. It mutated a little bit to have a much milder form of smallpox with only about a 1% mortality rate. because they don't really quite understand what happened to cause that. But kind of interesting. Vaccinia, then we'll talk about that. That is the vaccine that we use for smallpox was actually the Vaccinia virus. So it's not really an attenuated virus. I mean, it's a weakened, it's very similar to smallpox, to variola, but we didn't do anything to make that virus less infectious. It just happens to be so. This is a linear double-stranded DNA virus that's enveloped. You can see the capsid here. You can kind of see it here. We call that a complex capsid. It's actually, so let's change this, a complex, let's call it a complex capsid. It's not actually the largest. I fact checked this before class today. There are a couple other, there's one called Mimi virus that's actually bigger. This is one of the biggest viruses, but it's not the biggest. It does have a huge genome though, about 200 genes. So it comes into host cells pretty much carrying everything it needs. Of course, it has to take over the host ribosomes, but it has like all the enzymes and everything it needs to be successful. All right, so are you ready for this picture? This is a really nasty picture that makes me really glad we don't have to deal with this disease anymore. This, I kind of, I don't know, I kind of just put a little information here, and this is the slide where I wanted to add more. How is it transmitted? It actually can be spread by this infection by many different means. Most often droplet spread by saliva. Has the potential to be airborne within kind of short distances, but greater than 1 meter. Has potential to be spread by some fomite, maybe a blanket that was used on a sick patient, being used on another patient and getting them sick. Here's another figure that I wanted to share with you. It's estimated in the 1900s alone that worldwide 300 million people were killed just from 1900 on. And of course, we eradicated this in 1980 and we started vaccinating in the 60s. So that's just in those 50 or 60 years where the milder form of smallpox was circulating, 300 million people were killed. I checked that figure a couple times. It was just astonishing. In 1967 alone, 15 million people were infected. So again, we had the vaccine at that point. Still, just a horrendous disease, contagious, disfiguring. When those smallpox sores healed up, it often scarred, sometimes deadly. Just caused overwhelming inflammation. Patients went into shock, and that's typically what caused death. So vaccination, like I said, started in the 60s. The last documented case, I think, was in 1978, not in the US. And then we declared it eradicated in 1980. So we stopped vaccinating in this country in 1972. Okay, so we typically gave the vaccination to babies about their first birthday. So for me, don't do the math, I was born in 71. So I was wondering, I would have been like right at that age. Did I get it or not? And I asked my mom this week and she said, no, you didn't get the smallpox vaccine. Most of the time when you got the smallpox vaccine, I don't know if you can see this very well, but you tend to have kind of a lifelong scar from it. And I was trying to figure out what was it that caused the scar. Well, when you got a smallpox vaccine, it wasn't just a simple shot. I found this picture online. I didn't post it because I just found it this morning. They use a bifurcated needle for the smallpox vaccine. So, you know, that's blown up quite a bit, but it's got two little prongs on it. And when that's administered, you have to administer it, you poke up and down 15 times, all within, you know, like about a centimeter. So some of you have probably given vaccines. If you can imagine doing that to somebody like 15 times. Dr. Baxter had it when he was a young adult, and he said, it starts to hurt after a few times. So it's very painful. You get a sore pus. If you do it right, you start to bleed at some point, and you get this big sore that kind of gets really pussy. So you have to keep it covered because the vaccine, it's a live vaccine, and you can shed it, and then, you know, people can get it by contact immunity, which we don't necessarily want. So the vaccine had a lot of side effects associated with it. Dr. Baxter had it as part of a study where the US was trying to understand after 9/11 if their smallpox vaccines were still good. So he was a guinea pig. He said he was really sick for a couple days, nausea, headache, all that kind of stuff. But it turns out that people that have had smallpox vaccine should be immune to monkeypox. So kind of, you know, people over about the age of 52 or so probably have pretty good immunity to monkeypox. So anyway, so we quit doing this vaccine because, you know, by the early 70s, it was so rare and not in the US, but that, you know, it didn't seem reasonable to keep doing that. Oh, one other thing that I want to talk about before I move on to monkeypox is, so this is the first disease that we have eradicated. So what contributed, what aspects of the infection, so what contributed to eradication? It's not likely that we will be able to eradicate very many other infections. But the things that were kind of, again, a property of smallpox, that infection had very little antigenic variation. Okay, so that variola virus did very little. It didn't mutate very quickly. That enzyme that it carries with it, it actually carries its own DNA polymerase. It doesn't just use the host. It brings that with it, and it was really doesn't make very many errors, unlike a lot of other viral enzymes. So little antigenic variation, right? COVID, change. I don't think we'll ever get rid of COVID. And just as important, there are no animal reservoirs. Okay, so if we got a virus hiding out in squirrels or white-footed mice or whatever, we're never going to be able to get rid of all of it. And the other thing that made it a little bit easier to eradicate is that infected individuals are easy to recognize. Okay, they broke out in a rash, right almost to begin with. So again, you isolate them and hopefully not out there spreading it to other people. Okay. So how does that pertain to monkeypox? And by the way, as of November 28th, the WHO came out with a recommendation to change the name from monkeypox. It will be now known as Mpox. Okay, why did they do that? Well, they said that monkeypox name, when we change it to Mpox, that removes any confusion about how it's transmitted. So yes, you can get it from monkeys, but now, you know, we can get it person to person as well. And the Mpox name is an effort to reduce racist and stigmatizing language. So there you have it. Mpox, they're looking at other infections and thinking about renaming them too. All right, so yes, question. I think I don't know. Yeah, good question. If it stands for monkey, why don't we just say that? Yeah, I don't know. Good question. All right, so we are out of time. We'll finish up with monkeypox next time and start the RNA viruses. Look for some HIV stuff and COVID stuff to get posted. Have a good day. Oh, I just said that fever. If you have a fever.
Perfect. Thank you.
Yeah.